Hi, my name is Eli Kranzberg, and welcome to this new series on Omnisphere 2.0. This is a fantastic upgrade to an already great plugin, and in this series we're going to take a fresh look from the ground up and go through everything from A to Z. Let's start off by looking at the hierarchy and the architecture for how sounds are structured in Omnisphere. Now at the very top, Omnisphere is a multi-timbral software instrument, so we work within a multi. Even if we're only using one sound, one part, we're always working within a multi. Now, in a multi, you can load and play up to 8 different sounds, and they're called parts here. So multi consists of 8 sounds, each on their own unique MIDI channels, or they can share MIDI channels for layering, but up to 8 parts exist in a multi. Now, multis are used not only in the traditional way to set up 8 separate sounds and sequence them on 8 separate channels, but there's also a live mode and stack mode that's designed for live use if you want to layer and split sounds and change the way they're mapped on the fly. Now, multis store the entire state of the plugin. Now, underneath the multi, we have the individual parts. So each multi is comprised of 8 different parts, and each part can be thought of as its own kind of separate, unique synthesizer, and each part have full controls. They have their own oscillators, modulation routings, LFOs, effects, envelopes, etc. Now, the settings for each of the parts are saved within the multi when we save the multi, or you can just save it in your DAW that you're working in, and it'll all get recalled. Now, each part can also be saved on its own, and when we save it, it's called a patch. So we work with patches. Those contain all the settings of the sounds, and they can be individually loaded into any of the 8 parts. So we load patches into parts, and multis are comprised of the 8 parts. Now, the parts themselves can be split into layers. Each part has 2 layers, and we call them layer A and layer B, and each layer has its own complete, unique set of synthesis controls. So each layer has its own polyphonic oscillator as its main basic sound generating source, and you can use it in one of 2 modes, either in sample mode, where we use sound sources, or you can use it in a synth oscillator mode, which uses raw waveforms to generate the sound. So each part can mix and match the sound of the 2 layers together, and that's what creates the part, the 2 layers. And at the core of the layer, we have either sample mode sound sources or synth mode basic raw waveforms. Now, sound sources are based on a map of samples, the way we think of traditional samples. They can contain velocity layers, chromatic note mappings, loop points, but they also contain metadata like images and notes and tags, and this is really important in Omnisphere because it has such a huge library. We can search using this metadata as search criteria. And the synth mode uses raw waveforms, and we have up to 400 waveforms to choose from now in Omnisphere 2.0. And what's great about it is that the layers contain either the waveform or the sound source, but the actual LFOs and modulation routings and effects, that's all stored with the patch in the part. So we can experiment by loading in a patch and then changing the sound sources and superimposing them on the already existing LFOs and routings. So it's really easy to experiment with sounds and get good results quickly. So to summarize, Omnisphere is a multi-timbral instrument. We work within a multi, and each multi contains up to 8 parts, and we load patches into parts. And each part is comprised of 2 layers, and each layer can be based either on a sample mapping called a sound source or raw oscillator waveforms called synth mode. See if more in the next video.